Hi students, it's Teacher Mercy here again with a very interesting lesson in mathematics on natural numbers. Hope you're going to enjoy the lesson. Welcome. Natural numbers. Let's begin by talking about integers. And these are those numbers which do not have a decimal nor a fraction in them. They include both positive and negative numbers, 0 included. For example, we have -4, -2, 0, 1, 2, 3, 4, and so on and so forth. All those numbers are integers as long as they do not have a decimal nor a fraction part. Let's move on to whole numbers, and 0 and non-negative integers are called whole numbers. Now the numbers may range from 0 all the way to 100 and are called natural or counting numbers. They are also called natural or counting numbers. Even numbers are numbers that are divisible by 2, and odd numbers are those numbers that are not divisible by 2. Now prime numbers are numbers which are only divisible by 1 and itself. Examples of such numbers which are only divisible by number 1 and the number itself include number 2, 3, 5, 7, 11, 13, 17, 19. So between 0 and 20, those are the only prime numbers. Looking at them and their divisibility, they can only divide 1 and the number itself. Now we have composite numbers, and these are all the other counting numbers that are not prime numbers. So when we omit all the prime numbers, then whatever remains is a composite number. Yes, so examples of composite numbers are like number 2, 4, 6, 9, and so on and so forth. As long as it's not a prime number, then it's a composite number. Now we also talk about the place value of a digit in a number, and it refers to its position in that number, like we are going to see in the table following this. Now the place values of the digits in the number given are tabulated in the table below. Now we have a table here of all the digits in the number given above and their place value. For example, the place value of 8 is billions. Place value of 1 is 100 million. The place value of 2 is 10 millions. 4 just millions. 300,000. 5 10,000. 6,000, and so on and so forth. So those are the place values of a number, which we are saying it is the position of a number the position of a digit in a number. So the number 8124356789 in words can be read from the table above of the place values of all the digits in the number, whereby now it will read 8,124,356,789. The total value of the digits in the number above can be tabulated as below. So what we have talked about up there was the place value. Now we want to look at the total value. So the total value of the digits in this number as shown in this table. 8 billion. 1 is 100 million. 2 is 20 million. 4 is 4 million. 3 is 300,000. 5 is 50,000. 6 represents 6,000. 7 represents 700, 8 represents 80, and 9 represents just 9. So total value of each of the digits is as shown. Now, with numbers that have decimals, the place value of the first digit to the right of the decimal point is tenths. The place values of each of the digits in the number are like tabulated below. For example, look at our number 41.279863. So the 41 represents tens and ones. Then after the decimal, we begin with tens, hundreds, thousands, 10,000s, 100,000s, and so on and so forth. So now, the place values of those numbers are as shown in the next table. Now have a look at that table. We have the digits in the decimal number and we have their place value as I had said before. So just have a look at it. Most important thing, you should know that from the decimal point, you begin with tenths. Then it goes increasing like that. And remember, the ending of the name is THS, tenths, hundreds, and so on and so forth. So that is it. Our next subtopic is rounding off. When we are rounding off numbers, which are whole numbers, we consider their place values. Now that we've already learned about place value, then we can be able to apply it in the rounding off of numbers. For example, if we want to round off the number 54286 to the nearest thousand, then we shall consider the immediate lower place value, that is less than 1,000. Now, looking at that number, the digit in the hundred place is 2. This digit determines whether the value in the thousands place value will be rounded off from 4 to 5 or retained as 4. 2 is less than 5. If the digit is less than 5, there will be no rounding up. If the digit is 5 or greater than 5, there will be rounding up. Each digit to the right of the rounded up or retained digit is replaced with zeros. In the case of 54286, rounding off to the nearest thousand results to, now look at the digit representing hundreds, which is digit number 2. Therefore, it is not beyond 5. It's not 5 or beyond 5. So we shall not round off this 4. We shall not round it up. Instead, we shall leave it as 4 and replace all the other digits with zeros. So, to the nearest thousand, our number will be 54,000. It is also true that 54286 rounded off to the nearest 10. You look at the number representing tens. It is 8. Now, look at the one lower than it, which is 6, greater than 5. Therefore, that will make you round up the number 8 to a 9. Therefore, the number will be 54290. Then to the nearest 100, we look at the 100 value, which is 2. Look at the next digit, which is lower than 100. That is 8. 8 is a number which is greater than 5. Therefore, it is going to round up the 2, the digit 2 to a 3. Then you replace the other two numbers with zeros, so that we shall have 54,300. Now, to the nearest 10,000, we shall look at 5. 5, then we look at the lower digit, which is 4. the one which is just immediate after 5, which is 4. It's not yet 5. Therefore, what we do is we replace it with a 0 and the rest with 0. So we shall have 50,000. And finally, if we want to round off that number 54,286 to the nearest 100,000, then we shall look at 54. It is above 5. That digit which is lower than 100,000 is above 5 because it's a 5. So then that will change our digit into 100,000. So to the nearest 100,000, we have 100,000. Let's move on to rounding of decimal numbers. So previously we have rounded off whole numbers. Now we want to round off decimal numbers. For example, round off 4.5462 to the nearest hundredths. Now, we consider the immediate lower place value, which is thousands. Now, looking at that digit, it is digit number 6, which is greater than 5. Therefore, what we are going to do is we are going to round off the 4, which is representing the hundreds, to 5. So that our number is going to be 4.55. So in most cases, the questions we come across are rounding off a number to a given number of decimal places. For example, if you are told to round off 4.5462 to the nearest one decimal place, then you just check the first decimal place, realize that it's a 5, and the lower number after it is 4. So 4 cannot be rounded up. Cannot be used to round up 5 to another number. Therefore, we ignore it and we write our answer as 4.5. To two decimal places, again, we count 5 and 4. But you realize that the third number is a 6, which is a 5 greater than 5. Therefore, it's going to round off 4 to a 5. So, in two decimal places, our number is going to be 4.55. Our third question is writing the same number to three decimal places, whereby you will count the first decimal, second and third. Then the last one is a 2. 2 cannot round off 6 to a bigger number. Therefore, we just cut it off and remain with our three decimal places as 4.546. Significant figures. These are all the digits that are not digit 0 in a given number, and at the same time, the 0 digits found between the non-zero digits of a number are counted as significant figures. So, two numbers. Number 1, non-zero digits in a number, and number 2, zeros which are found in between the non-zero digits. Those are counted as significant figures. Now, for example, if you have a number like 0.0254, 201, 3.450, and 87500, all these numbers have three significant figures. Look at them. The first one, the 2 zeros are not significant. So 254 is 3 digits. Now 201, there is a 0 there, but it is found in between the two non-zero numbers. In the third number, 0 is on the other end. So we do not count it as a significant figure when it's not in between. Then finally, the last 2 zeros in the digit 87500 have have no significance in that number. Therefore, that number is still a 3 significant number. Now, let's look at 2634. We round it off to 2 significant figures. What is it going to be? You just pick the first 2 digits. Check whether the third one can round up the second, of which it's a 3. It cannot. So we just replace the other two numbers with zeros. So we just have 2 6, then 2 zeros. Now in 3 significant figures, we shall pick the 3 digits, the first 3 digits, that is 2 6 3. Check the last one. Can it round up a number here? No, it cannot, because it is less than 5. Therefore, we replace it with a 0. Now let's look at 17.4938 rounded off to 5 significant figures. Now, we first count starting from digit 1. Then 7 is 2, 3, 4, 5. The 5th digit is 3, but the number lower than it is a 8. So that 8 can round off 3 to a 4. Therefore, into 5 significant figures, that number will be 17.494. Now, into 4 significant figures, we are going to count 17.49. The last digit there, okay, not the last. The digit following 9 is digit 3, which is less than 5. Therefore, it cannot round up 9. So we just ignore it and we have our value as 17.49. Then to 3 significant figures, it's going to be 17.5. I hope you can see why we are having 0.5 and not 0.4, because the digit that follows 4 is a 9, which is greater than 5. Therefore, it's going to round up the 4 to a 5. And to 2 significant figures, we shall just have 17. Now, rules for assigning significant figures. Number 1, all non-zero digits are significant. Whenever a number has a non-zero digit, then count it as a significant figure. Number 2, zeros that are between other digits are always significant. For example, a number like 3002. Those 2 zeros are significant because they are in between 2 non-zero digits. Final zeros that occur before or after decimals are always significant. Final zeros that occur before or after decimals are always significant. For example, look at 78.00. Those 2 zeros are very, very significant. Finally, zero used for spacing the decimals are not significant. Zeros which are used for spacing decimals are not significant. For example, 0.0032. Those 2 zeros are not significant. That marks the end of our lesson today. May you do as much practice as possible. Let us call it a day till we meet again for the next lesson. Be blessed.